Hey everyone, welcome back. In this section, we will talk about face detection using deep neural networks. In the previous section, we have seen how to do the face detection using Viola-Jones algorithm, that is, using Haar features. There are few disadvantages with the Haar features. It may not work accurately for the most of the faces. And the modified version of Viola-Jones technique applied to the deep learning models, and that is widely used face detection model. In this section, we will see how to deal with deep learning based face detection using OpenCV. OpenCV also provides a deep learning based face detectors. More specifically, the OpenCV Deep Neural Network DNN face detector is based on single shot multi-box detector, also known as SSD, which is a framework using a ResNet 10. OpenCV 3.1 Plus supports DNN module, which implements a forward pass with a pre-trained deep neural networks using the popular deep learning frameworks such as Caffe, TensorFlow, Torch, Darknet. In this section, we will perform the face detection using pre-trained deep learning face detector models, which included in the library. OpenCV provides two models for the face detection. Face detection FP16, which is a floating point 16 version of original Caffe implementation, and face detector U88, also known as unsigned 8-bit integer, which is 8-bit quantized version using TensorFlow. In each case, you will find the two set of files, the model file and the config file. In case of Caffe model, these are the following details. You can download the models from the URL available here. Also, if you want the TensorFlow model, you can also download from the URL available here. Coming next, we will see face detection using deep neural networks in OpenCV Python. Until then, happy learning. Welcome back. In the previous lesson, we have seen how to download our models. So make sure you have downloaded the models in the respective folder and also open the Jupyter notebook. So in this lesson, we will see how to do the face detection using the deep neural networks. This time, I'm using the images that was there in the images folder, and the image that was working on in this lesson is faces.jpg. So please download this image in the resources. Now let us open the Jupyter notebook by new Python 3. Change the name of the notebook to face detection underscore DNN. Alright, I guess you guys are ready. Let's kill it. First, import NumPy as NP and also import computer vision library CV2. Import NumPy as NP, import CV2. And the next step is that let's load the data or image that which we want to apply the face detection model. So load the image. So the image is img equal to cv2.imread, and the name of the image that I want to load is in the images folder. It is faces.jpg. Let's display the image cv2.imshow, and it is faces, and the name of the image is img. Let's provide wait key and destroy all windows. Execute it. Okay, these are the three beautiful faces. Let's do the face recognition algorithm to it. Let's detect the faces using deep neural networks. The next step, what we need to do is that obviously we need to load our model. Let's load the model. Net equal to cv2 dot. Since my model is in the DNN module, let's use a special module in OpenCV, that is DNN dot. Now what you need to do is that load the model using read net from Caffe. Since I'm using the Caffe model, that's why I'm using the read net from Caffe. If at all you want to work on the TensorFlow or Torch, use the appropriate function that will read your model. Since I'm working on Caffe, just select the Caffe. Now what it is asking is for prototext and Caffe model. Let's provide it to it. That was there in my models folder, and the first one is that deploy.prototext.txt. Next, provide the name of the model, that is my Caffe model, which is my ResNet 10300 by 300 SSD. Select it. That's it. So this is how I need to select the model and then load the model. Now let's execute it. Perfect. Now you have successfully loaded your model. Now the next step is pass the image to the model. It is not a pretty straightforward process passing that image to the model. Instead, the first step what we need to do is that we need to extract the blob from the image. So for that we use a special library DNN to extract the blob. Extract blob. So blob equal to cv2.dnn blob from image. Now what is the image you want to extract the blob? The image that I want to extract the blob is img and the scale factor is 1. The next step is the size at which I want to reduce. Remember, the size you want to reduce is this. That is 300 by 300. Model will accept the image in the 300 by 300. So what we need to do is that we need to resize the image to 300 by 300. So let's do it here. 300 by 300. Inside there is a image transformation function. Resize will be there. That will resize it automatically. The next step is mean. We need to provide the means of a BGR, that is mean for B, mean for G and mean for R, and blob will basically calculate the subtracted mean images. So let's provide those values. And the mean for blue is 104, for green it is 117, for 177, and for red it is 123. So that's what we need to provide. And the next one is swap RB. OpenCV assumes that you have read an image in BGR format. If you read an image in RGB format, then set swap RB to true. Otherwise, set swap RB to false. Since I read an image in BGR, I'll set swap RB to false. Done. Execute it. So here what we have is that we got the blob. So let's pass this blob to our model. Set the blob as input. Okay, you can set the blob as an input by net.setInput. So what is the input for the network is my blob. Now let's run it. Run the model. Net.forward. Basically we are doing the forward pass operation. Forward pass operation means we are not changing any weights to it. What are the weights that was there? We are directly straight away using that weights. We are not at all changing anything. Obviously that's the case, right? That's a pre-trained model. It will work very great accuracy for the faces. So let's use the same weights. So for that I'll use as forward. And the output for that is the detections. Execute it. Done. Now you have successfully got the outputs. Let's look into the output here. Detections.shape. We have an output in the fourth dimension. Let us investigate this output. Okay, so I pull up my PPT and you can see that what we have is the detections.shape. And the shape what we got here is 1, 1, 200, 200. You don't need to worry about this 1, 1 is basically we'll talk about the number of images. So currently we are working on only one image, that's why we got 1. And the next important thing we need to understand is this 200. 200 means that model has detected the 200 faces. It doesn't mean that in that picture has 200 faces. It gives a probability that the object that is detected as a face or not. That information is there in 7. In 7 we have the 7 values. The 0th index is an image number and obviously it will be 0. And the first index is binary, whether it is 0 or 1. 0 indicates that the box, whatever it is detected, is not a face. And 1 indicates that what are the box it is drawn and it is indicated as a face. And the index number 2 has a corresponding confidence score of the face. And 3, 4, 5 and 6 gives you the coordinates of the face. 3 and 4 has the start x and start y, means xy position of the face. And 5 and 6 consist of index and ny, means xy position of the one more face. Basically these two values 3, 4 and 5, 6 are the two diagonal points of the bounding box. Using that you can draw the rectangle. So we'll see now how to draw the rectangle on top of the face. Let's go back again. Now I hope you understand what exactly this detection is. So let's look into the confidence score of each and every detections. So for that, let me use a loop for I in range of, since we have detected the 200 faces, let us see the confidence score of all 200 faces. So for I in the range of 0 to detections dot shape of, just provide this 200. For that it is index number 2. Done. Now confidence equal to detections of, obviously this is a 0 comma 0 comma, and this is what basically it consists of, like the face number. So let me give the I, and the index position number 2 here will give the confidence score. Let's put 2 here. Now let us print the confidence score of all the faces what we got. Execute it. Here you go. What you can see is that we have the 200 faces and their corresponding confidence score. You can see the lot of faces has a probability of 0, which basically indicates that there is no face. So I think there are a lot of faces out there that has been detected. It is important to note that we need to set some threshold point to the confidence. Generally, it is a good technique to select the confidence more than 50%. So that's the reason what I'll do is that I'll select only the faces which has the confidence score greater than 0.5. So if confidence is greater than 0.5, greater than or equal to 0.5, just select it. Let's print the confidence. Now execute it. Here you go. What you can see here is that we have the 3 faces and the corresponding confidence score. Awesome, right? Obviously, in our image, what are the image I consider as 3 faces, and if I set the confidence is greater than 0.5, I got the 3 faces. That's really cool, right? Now what we'll do now, shall we draw the bounding box? Let's go. Now bounding box. Okay, so the bounding box information is there from the index 3 to 7. So now let us take the box equal to detections, select the appropriate face which is I, and now select from 3 to 7, which will give you the bounding box. But remember, this bounding box, whatever you are going to get is the normalized values, which is the normalized bounding values, bounding box values. Means you will get the values which is normalized to width and height of an image. Let's print the values. We can see that the values whatever we have is this values, and all the values in the range of 0 to 1, which is normalized to width and height of an image. In order to denormalize this, what we need to do is that we need to multiply this with width and height of the image respectively. So let us calculate the width and height of an image. H, W equal to, let's check the image dot shape, and obviously what you'll get is that shape will give you a number of rows and number of columns. Rows will define height of an image and the columns defines the width of an image. So let me select only 2 values. So we got height and width. And now what you have to do is that we just need to multiply with height and width of this boxes whatever we are available here. Okay, so now what we will do is that let me multiply this with box into np dot array. Obviously this is start x, start y. I just need to multiply that with width and height, and again width and height. So with that what I can get is that I can get the denormalized values. Let me print this. Here we go. What we got here is that denormalized values. But remember, OpenCV will not allow this kind of float values because image is an unsigned 8-bit integer. So that's the reason what we have to do is that we need to change the data type to unsigned 8-bit integer values. So let us change the data type to integer. So for that what I can do is that box equal to box dot as type, change that to integer values. Now let us print the box here. Here we go. You can see that we have the values in the integer. I guess now you guys are ready now. Let's take the coordinates and let's draw the rectangle box on top of the face. So what we will do is start x, comma start y, end x, comma end y equal to box. Now you got start x, start y, end x and end y. And the next step is draw the rectangle. So the rectangle will be cv2 dot rectangle. In what it will provide here is that image img. Next start x then start y, which is my point 1, and end x, comma end y, which is my point 2. And next provide the color which is my green color 0, 255, 0, and thickness let's leave as it is. So that's it. This function will draw the bounding box on top of the face what we got. Now let's display our image. cv2 dot aim show, and the name of the image is face detect, and the matrix is img. Now cv2 dot wait key and cv2 dot destroy all windows. Execute it. Awesome, right? You can see that your deep neural networks can able to detect the face accurately. Shall we put the confidence score on top of this box? Yes, of course we do. Let's do that. So in order to put the confidence score on top of the box, first thing what we need to do is that we need to put the text. We know that in OpenCV there is a module called put text. Let's use it. Put text, and for which image I want to put the text, it is my image. And what is the text I want to put? Let's put the text at the time being, and org is basically the origin at which I want to put the text. And origin I want to put the text is start x, comma start y. Since I just want to show you some difference between the box and also the text, that's the reason I'll subtract that with 10 pixels. And the font face is need to provide the font. So in CV2 we have the font underscore. Let's select the plain font. Next font scale is 1. Color, this time I'll select the white 255, 255, 255, and thickness let's leave it as it is. Now coming to this text equal to, basically I want to print the confidence score. I can get the confidence score from this and just convert that into text using this format. And confidence, and what you'll get the confidence in the value from 0 to 1, but I just want the confidence in the percentage, so that's the reason I will multiply that with 100. Now I can get the confidence in the 0 to 100, but here I'll get the multiple decimal points. Let me limit that into few decimal points, which is by using colon dot to f. So this will basically give you only 2 decimal points. And before that, what I'll do, let me say it is a face, saying that I have detected the face. Okay, and after this let's put the percentile here. Means that I might get 99.9%, 80.9%, something like this. So I think we guys are ready now. Let's execute it. Awesome, right? You can see that we can able to detect the face, and top of that we have the probability or confidence score of this face, which is 99.95, and for this it is 95.80, and for this face it is 80.42. It's really cool, right? Your deep learning model can able to detect the face such a high accuracy. Now you guys can work on what are the images you want and see that, like, how well and how accurately your model can able to detect the face. I will see you in the next lecture more on this. Until then, happy learning.